Welcome back onto theCUBE. Here at theCUBE's NYSE studio, of course, we have our Palo Alto studio, connecting Silicon Valley and Wall Street. This is part of our physical AI series here at the NYSE, part of the NYSE Wired program, a CUBE original, open community and a network of leaders making it happen. Noah Ready-Campbell's here, founder and CEO of Build Robotics, back for his visit. CUBE alumni, a year ago we were here in theCUBE. Welcome back, good to see you.
Hey, good to see you.
Coming on.
Thank you.
So last year we talked about physical AI. You had probably one of the coolest stories. When people think robots, I think humanoids are factory. You have big robots, and you had them working on large projects with solar, digging trenches. Like, it was a really great use case. And now you got updates. So first, re-explain this context, what you guys are doing, so people can know what you got going on. Explain the quick elevator pitch.
Yeah. So I started the company 10 years ago, and I really had this insight that autonomy was coming not just to self-driving cars, but also to the off-road world, to heavy equipment, to construction. Over the first few years, we kind of developed a number of different robots and deployed them into residential construction, building foundations, into wind, into oil and gas. And then about 5 years ago, we realized that solar was just booming, and solar was really where we wanted to focus. And there's kind of two factors there. One is that, yeah, the solar industry has been growing like crazy. If you look at solar plus batteries today, there are over 80% of new energy infrastructure that's being constructed in the United States. 10 years ago, solar was alternative energy, and now it's dominating the energy landscape, which has been a remarkable transformation to see. The other thing is that solar is kind of uniquely well suited to automation. Solar farms are these huge horizontal projects. Yep. The largest solar farm we've worked on was like 15 square miles, to give you a sense. And they require very long trench runs where you're putting buried cable underground, and that's one of the things our robots can do. And they also require hundreds of thousands of steel panels, or steel piles to be driven into the ground. And that's the other sort of main focus for our robots. So solar is continuing to grow. That's really the story of Built right now.
Yeah, and I remember talking, what I found fascinating is that it's hard to imagine, but we can all see, we've all probably passed a solar farm, maybe not 15 miles by 15 miles, but like, it's a lot of panels. Yeah. So it's huge. So there's a lot of digging, a lot of heavy equipment. And just to kind of rehash this, scope the size of the robots so people know what they're looking at here. It's literally, they're not like little robots.
Yeah, so our robots can be up to maybe 100 feet across. They tend to work in teams of two, and that team is about 100 feet from one side to the other, and they can weigh 150,000 pounds, 200,000 pounds. So if they're fully loaded, including the weight of all the piles that they're carrying. So
and give some examples of the tasks that they're doing. Trenching is easy to see. I know that's a no-brainer. Yeah. But other one, moving heavy equipment around?
Material handling, so carrying these steel beams and then actually driving them into the ground. So you can imagine a pile is a steel I-beam, basically, up to 20 feet long, that up to maybe 800 pounds in weight. And the robot has a gripper, so it's able to kind of reach in there and grab the pile and then pick it up and then drive it into the ground. So they're typically being driven literally within a few millimeters of the design, easting, northing, and elevation. So extremely precisely. And as I mentioned, these are big, heavy beams. So there's a real safety improvement that our robots are able to offer.
Talk about the alternative. If you had to do it with a team, you need a crane, you need labor. I mean, just scope that difference with and without.
Yeah. So it's kind of multiple steps that are all getting compressed into one using automation. So for specifically looking at piling, usually you have a surveyor come out, and the surveyor puts what they call feathers or survey markers on the ground, and they're different colors to show you which different type of pile goes, in which location in the field. And the largest projects that we're on can have upwards of 50 different colors. So just even getting all these feathers in the ground in the correct locations is a real task. Then there's what's called pile distribution or shakeout. And so that's a guy with a forklift, a rough terrain forklift, who's driving out there. And it's typically two people who are sliding those piles off the forks of the forklift. And so that's a whole activity. And then there's the actual pile driving. It's typically a two-person crew. So you drive out there with the pile driver, And then there's a guy whose job is, he's the rigger. So he basically lifts the pile up and kind of attaches it to this lanyard, and then it gets lifted up into the air and driven into the ground. So that can actually be a relatively dangerous activity. If you imagine an 800-pound pile that's kind of swinging in the wind or something, you don't want to get too close to that.
Yeah.
And then the last step is quality control. So after the piles go in the ground, they need to be measured. They need to get kind of bumped and twisted so that you can install racking on them. So.
All right, so what's the update since last year? Deals, momentum?
Yeah.
Give us an update on progress, company,
absolutely,
revenue, customers.
Well, I can't tell you all that, but no, so speaking of the traditional means and methods, one of our customers this past summer did a time study. And what they found was that if you looked at the number of piles that could be installed per craft hour, per labor hour, we're actually seeing about twice as many being installed using our robots. So there's a meaningful improvement in productivity, and obviously a meaningful improvement in safety too. Just taking people out of harm's way. And the other thing I can share is that we've signed a deal with Quanta. So Quanta, largest specialty contractor in the U.S., publicly traded, $50, $60 billion market cap. And we're now installing piles for them on a number of different projects around the country. So yeah, things are going great for the business.
So yeah, good contracts. Robots are deployed. Backlog of robots. What's the order cycle? I mean, you're making them fast enough. How long does it take? What's
Big
the
backlog.
constraints?
Big backlog, yeah. So honestly, we're just trying to buy excavators fast enough, because that's one of the cool things about how our robots work is, we buy an excavator from an OEM like, Caterpillar or John Deere or whomever, and then we upgrade it and we turn it into a robot. So it's very similar to what Waymo does for one of their Jaguar cars. We're just having a hard time getting enough of the type of excavator that we need. So we're actually placing orders to the factory and, custom made to our specification excavator.
So you're retrofitting,
yeah,
like Waymo. Because Waymo's not a true L4 robotaxi.
Well, we like to say upgrade. But yes, no, exactly. And the reason for that is that we think that the OEMs, they've perfected the hydraulic excavator over the last 50 years. And we want to stand on the shoulders of giants. We don't think it makes sense for us to go out there and try to beat them at their own game. Instead, we're buying something from them. It's a win for them, and then we're adding the AI in order.
I mean, it's a huge risk to vertically integrate this. It's not a lot of economic downside for you to do that.
Yeah.
When that opens up doors for safety, malfunctions,
yeah,
quality.
Yeah. So
they got that locked in.
They do a great job. I mean, they build a great product. And the other thing I should say too is that they have the dealer network. So there's, if anything goes wrong with the machine, you can call up a service tech and you can get somebody out usually the same day. And so that's really valuable as well.
All right. So what's the coolest thing that's happened last year for you? Or
I mean, signing this Quanta deal was pretty big one for us. And we're also fortunate to work with some of the other top 5 solar EPCs. So, we're seeing awesome traction. Something that I don't want to celebrate at all, but I think it is worth pointing out, is that, with the war going on in Iran right now, gas prices are up to a tremendous amount, I think 50% since the beginning of the year. And that just makes the economic imperative to use renewable energy, to use solar power even stronger. And so that's certainly powering a lot of demand.
I mean, even though if it does level down, you mentioned earlier, it went from alternative energy, solar, to with electric booming, cars, everything's kind of tied in.
Data centers,
This is becoming the standard.
Absolutely.
And how far are you happy with the progress on the technology and all the viability?
I mean, I always want to be moving faster.
Yeah.
And I think, we're looking at a number of different applications to help accelerate the solar build out. So, not just trenching, not just pile driving, but, mass grading, site prep, material handling, panel distribution. I think that the overall opportunity for solar automation's several billion a year in revenue here.
Well, you got your hands full on the product side. What's coming down the pike? What are you focused on the product side? Can't build them fast enough, sounds like.
Yeah.
What's your goals for the year? What are you working on?
So one thing that we've invested a lot in over the years here is our AI safety system. We call it Project Theia, because Theia is the Greek god of vision. And so it allows the robots to basically see the world around them and then accurately perceive potential safety hazards. And we've done a bunch of bake-offs, and we've looked at the quality of our safety system, and it's actually better than anything else out there. So it's better than commercially available solutions, and it's better than the open source things, like maybe you've heard of YOLO. You know, it's one of the most popular AI perception models. And we think that there's an opportunity to give back to the community. And so what we're looking at right now is actually taking that and figuring out a way to either offer it to other startups or maybe even open source it. We're looking at some collaborations with some different research institutions right now. So that's something that we're going to hopefully be pursuing later this year.
Well, certainly, let's keep in touch. Definitely love having you on our Physical AI series because you encapsulate what Physical AI is, because you're applying and executing a specific thing in a market where there's a huge need.
Yeah.
You get the advantages: cost, benefit, time, labor,
safer, faster,
safety.
cheaper. Yeah.
Good fronts on safety. Thanks for coming in. Appreciate it. Good to see you.
Yeah, thanks, John.
All right, I'm John Furrier, host of theCUBE here at the Physical AI series, part of our NYSE Wired program. It's a theCUBE original, of course. theCUBE covers the deep tech, and together we're covering all the angles, doing our part here on theCUBE. Thanks for watching.